Hello, good afternoon, everyone. Welcome to one more amazing session from Infinity Learn. How are you all? Welcome to Happy New Year 2025. So, please confirm, am I audible? You can see me. Please confirm in the chat box so that I can see you. Right? Wonderful. Welcome to one more amazing session from Infinity Learn. So, today we are going to discuss about amazing methods for these chemical bonding. So, when you talk about any part of chemistry, so it is connected to chemical bonding. ये केमिकल बॉन्डिंग में कुछ कुछ टॉपिक होता है, अलग अलग टॉपिक है, कनेक्ट करके एक ही वक्त में आपको ये जो टॉपिक है कैसे इस्तेमाल करना आपको बताना चाहता हूँ आज के लिए. हाय मोनिका, हाउ आर यू? हैप्पी न्यू ईयर. So before going for this, I'm fine, thank you Betty. So before going for this chemical bonding concepts, I just want to give a kind of motivational stuff. Like you see, there are 4 students that are displayed here. What Infinity Learn is doing for the students preparing for your NEET examination. Hi, Mayor. Hi, how are you? Happy New Year. So you can see Ashrita, Akil Verma, Hema Dyuti and Satyanarayan. They got 2023 score and 2024 score. Ajay Kumar, Happy New Year, Monica. Ajay Kumar, hi. Mayor, Major Mayor, wonderful name. So you will get a major score in the NEET 2025. You are all preparing for NEET, right? So in this 2024, it was, we started preparation NEET for in the Infinity Learn YouTube platform, and we are stepping into 2025 to crack NEET examination. Happy New Year to you all. And you can see Ashrita got 310 marks in 2023 and she got 661 marks in 2024. You see 351 marks increased. Okay, hi. Hi, I'm fine, thank you. Happy New Year. Tutu, what's name? Tutu Quado. Okay, anyways, Himadyuti, just like Ashrita, she got 310 marks in 2023 and 652 marks in 2024, 342 marks increased. And you can see Akhil Verma in NEET 2023, 313 marks and 658 in 2024, 345 marks is increased. Pritu, hi. And you can see Satyanarayan, he got 330 marks in 2023 and 2024 650 marks. There is a huge increment of 320 marks. So when you just compare these structures, you will be seeing here the score is almost doubled. How it is possible? Yes, it is possible because they attended the classes from the Infinity Learn, the faculties from the Infinity Learn guided them, they followed it, they enrolled some courses, they attended YouTube sessions like you as well. And in 2025, in this slide, you will be the next. Are you ready for that? Yes. Crack your NEET examination, grab your medical college seat, in a premium medical college seat, and for that attend the lectures every day without any fail. And if not able to attend, at least watch the recordings, and you please like the session and share with your friends and subscribe to NEET Infinity Learn channel. Okay, so ready for that, and I want to show you SEO test prep with Infinity Learn, and you have Infinity Learn app. On the Infinity Learn app, you will be having various features, outstanding features like live classes and mock test and create your own test and 24/7 doubt resolutions here. And also you will be having we have Infinity Learn on the social media, especially Instagram and Telegram channel and many ways. So I just suggest you join in Infinity Learn Telegram channel. In the Infinity Learn Telegram channel, link is there in the description box. Everybody just click it and just proceed to that. So you are going to have everyday daily quizzes are there in the Telegram channel. Session schedules be here and session notes also and assignments and many more. And why late? And very important thing, आजकल आर्टिफिशियल इंटेलिजेंस का हालचाल ज़्यादा चल रहा है. Yes, we are stepped into the era of artificial intelligence where Infinity Learn is the first one in education sector in India. We are giving training, coaching, teaching, everything by using AI systems. So that is pathway to academic success, Infinity Learn journey with artificial intelligence here, learner's journey. And in that you can see goal setting, set your academic goal and skill enhancement program. एंड अब जो कर रहे हैं ना, करने का जो आपका जो तरीका आता है ना, प्रोग्राम AI बनाते हैं. एंड यू विल बी हैविंग आउटस्टैंडिंग लाइव क्लासेस बाय एक्सपर्ट फैकल्टीज. एंड यू कैन सी टेस्ट एंड पेपर एनालिसिस and meticulous in-depth analysis by AI tools, and also self-study, learn, practice and revise. And you can see conceptual videos, mock test and practice test, and also flashcards. आप जो भी कर रहे हैं ना, एक बार रिवाइज करने का आपको जो चीट शीट फ्लैश कार्ड चाहिए. And also and test and paper analysis, and last but not least here, बच्चों, doubt resolutions 24/7. Any doubt at any time, just your doubt is going to be one click away. So you're going to get answer powered by AI. In a day, thousands of doubts are being clarified by using these doubts. While it, you just scan this QR code and download it and enjoy it. So wonderful, my dear students. One more thing, I am going to present you India's largest scholarship examination, score examination. This score examination is online and it is from grade 3 to 12. Why it is India's largest scholarship exam? Pritu, Monica, you just see, just give me 2 more minutes so that we can start the concept better. And scholarship worth of 1 crore rupees. And study setup and laptop BA. And educational allowances and scholarship up to 1 crore rupees. And scholarship 100% जो भी कोर्स आप मानना चाहता हूँ इसके लिए. And you will be having, and description box you are having the link and you click that link and you proceed to that. So you can enjoy the outstanding score examination. Click it and enjoy all the facilities. Okay, Monica, fine. And at last, this is the last slide before going for this concept review. NEET 2025 All India Test Series. This test series, I suggest whatever you prepare, whatever you study, it has to be checked with a proper examination system, internal examination system. That is what is an assessment system. And appropriate assessment and scientifically designed assessment system is incorporated in the NEET 2025 All India Test Series pack. उसमें आपका क्या क्या चीज मिलेगा? 27 AITS एग्जामिनेशन, उसमें 13 यूनिट टेस्ट है, 4 पार्ट टेस्ट एंड 10 ग्रांड टेस्ट है. इट इज बेस्ड ऑन नीट पैटर्न. बच्चों 20 ऑनलाइन नीट फुल सिलेबस मॉक टेस्ट भी है, एंड 25 नीट टॉपिक वाइज प्रीवियस ईयर क्वेश्चंस, and 3 physics chemistry books along with video solutions on the app, and detailed solutions and performance reports on every test. And last but not least, your test performance is benchmarked with Sri Chaitanya students, so that what happens, you will be having appropriate like insight or how many marks you may get, everything prediction will be there. And these many facilities in India, who is going to give? The cost is 5,999, and after discount and a limited time offer 50% उसमें discount मिलेगा. You will be giving YouTube 50 off. ये coupon code enter करने के बाद, once you applied this coupon code, you are going to get it is for 2,999. And while it, you can enjoy this, and all the best for your NEET 2025 examination. Right? So we'll start the class. So presentation is over. Let's see the chemical bonding. In chemical bonding, you just focus on valence bond theory, VSEPR theory, hybridization and bond parameters, and you have molecular orbital theory. These are the 5 areas where chemical bonding has to be studied. And while it, we'll just focus here. So valence bond theory. According to this theory, a covalent bond is formed by the overlapping of atomic orbital between 2 bonded atoms. So the condition for the overlapping, The overlapping orbitals. Hitler and London has given first this concept, later and Pauling and Slater developed this. And for a covalent bond to form, two atoms must come closer, and orbital of one atom should overlap to the another atom. Shirani, Mira Shirani, good afternoon, Happy New Year. And for the overlapping orbital must we have, these are the conditions, bacho. Based on these conditions, half-filled nature must have unpaired electrons in the overlapping orbitals, and anti-spin electrons AB or a condition A. So whenever orbitals are overlapping, the orbital should possess unpaired electron, ये पहला जो condition है, and overlapping orbital should have opposite spin. That is what is a anti-spin electronic configuration, and these are the conditions for this overlapping. And also, as a result of overlapping, a new localized bonding orbital is formed, and in which the probability of finding of an electron in the bonded orbital should be maximum, and that result in the covalent bond formation. So, bacho, we can go ahead. Covalent bond arises, the energy arises due to these two factors: electrostatic force of attraction between the nuclei and the accumulated electron cloud between the two bonded nuclei, और एक चीज है, and cancellation of attraction between the spins and anti-spin of the electrons, तभी ये bonding energy मिलेगा. And that is actually greater is the overlapping, stronger is the bond. So bond strength depends on the extent of overlapping, and this overlapping is of two types. One is a coaxial overlapping, that is also called as axial overlapping. Another one is called lateral overlapping. So let's go ahead with that. Okay, so Pauling, Linus Pauling and Slater given an extension. You know, Linus Pauling, I like this scientist. Roshni. Pauling got Nobel Prize for twice in two different areas. One is in this area, chemistry, and another one is in the Nobel Peace Prize. And he is actually the father of, you say, modern molecular biology. He is not related to the biology, still he is said to be the father of modern biology, modern molecular biology. And also Pauling just incepted the concept, developed the concept of hybridization, and he is the one who just given inception for the concept of electronegativity. Everybody even today follows the electronegativity scale, Pauling's scale. So such a versatile scientist, I like him. Okay, anyways, Pauler and Slater given the extension of the valence bond theory, bacho. Hi, Miraj, Happy New Year. Roshni, Happy New Year. Everybody, Happy New Year in the class. There are hundreds of students that are seen. Okay, for everyone, my best wishes, and my best wishes for your JEE exams, NEET examination that happened in the 2025. Okay, get ready for that. The extent of overlapping depends on two. One is nature of orbitals involved in the orbitals, and the nature of overlapping. And more closer the valence shells or the nucleus, more will be the overlapping, and more is going to be the bond energy. So the overlapping takes place between two atoms which are making the overlapping between shell number 1 to shell number 1 is a stronger bond. Shell number 1 to 2 is more stronger than shell number 2 to 2. Like that, as number of shells increases, overlapping extension decreases. That's very important. So if the shell number is same, that is going to be directional property comes into the picture. So that PP overlapping is always stronger than SP overlapping is always stronger than SS overlapping. In that, if the shell number is the same, mind it. First rule is shell number, second rule is PP greater than SP greater than SS. Roshni, fine? And also S orbital spherically symmetrical and those show low head-on overlapping, while the p orbital are directional, they show more directional properties, so that their extent of overlapping is going to be more. more is the extent of overlapping, stronger is the bond. That's what I want to say. So formation of sigma bond, you can say a axial overlapping is called as a sigma bond. What is a axial overlapping? If you draw a line along the bonded nuclei, that is called as axial overlapping between two s orbitals is called s sigma bond. Bacho. And s orbital and this is a p orbital, and there is a overlapping between s and p, that is called sigma sp overlapping. And also you can see p orbital to p orbital, that is called sigma p orbital. Okay, Monica, you can see formation of sigma bond is only on head to head overlapping or axial overlapping. So my dear students, here it is a live interactive session, it is not a radio session. So what I mean to say, please ask any kind of doubts by using chat box, so that we can have a very good transaction between you and me. And this YouTube classes हम पैसा कमाने का नहीं कर रहे हैं, बच्चों के लिए कुछ भला करने का कोशिश करता हूँ. So please use this facility. It is full free of cost and you can enjoy these classes. Bachcho, you can see this overlap, this is the bond axis. The overlapping jab takes place laterally, that is called as a pi bond. Are you getting or not? Fine. And sigma bond is stronger and pi bond is weaker. Sigma bond is formed by a pure orbital as well as a hybrid orbital, whereas pi bond is formed by only pure orbital, hybrid orbitals, s orbitals. Pi bond kabhi form nahi kar sakte. Okay, and pi bond formed only the formation of a sigma bond. Monica, है ना? So ये opportunity आप लूटने का कोशिश करो. That's the reason why always, my dear students, please follow our classes. And also head-on overlapping is stronger than lateral, and lateral sidewise is called as a pi bond. Are you getting or not? Sigma bond is stronger than pi bond. So that bond energy lateral is less than head-on, pi bond is less than sigma. When it comes to the sigma bond, PP overlapping is stronger than SP overlapping is stronger than SS overlapping. Yes, Sharani, yes, okay. पहले आप मिराज शरानी हैप्पी न्यू ईयर बोला. पहले मैं कितना बार बोला आप लोग को? ओके ओके, when you wish somebody, okay, Rashni, Miraj, okay, Tutu and Ajay Kumar, Major, so many students are there. The way we wish each other gives the energy and vibes, huh? Yes, okay, that's the way. And following overlapping is not possible in the NEET examination में. आपको सीधा एक क्वेश्चन पूछा जाएगा NEET में. So which of the following is possible, which of the following is not possible? मैं इसके लिए एक ट्रिक बताना चाहता हूँ. एंड ओवरलैपिंग ऑर्बिटल्स का डायरेक्शन सही होना चाहिए. द ओवरलैपिंग ऑर्बिटल शुड हैव appropriate orientation. That is the first point. And the second point is overlapping orbital should have nearly the same energy. Okay, so you want to form a bond between 3p orbital and 3d orbital, nahi hoga. Okay, so that you can see kind of internuclear axis. So whenever this s orbital and p orbital is a internuclear axis होता है, ऐसे overlapping मना है. ठीक है बेटा? And here also in s orbital total overlap is going to be 0 and it is not having a proper direction. So this overlapping is not possible. And a minus and a plus, this overlapping is not allowed because they get cancelled. Whenever you can see the overlapping like this, यहाँ पे प्लस एंड प्लस पॉजिटिव ओवरलैपिंग होगा, ये हो सकते हैं. मोनिका, राइट? एंड whenever you say minus and plus, okay, ये भी possible है. Minus minus become plus, no? And I want to say minus and a plus, ये not possible है. Are you getting or not? Clear? And you want to say lateral overlapping also. This is possible. This is possible. This is not possible. So which of the following is possible, which of the not possible, you have to identify from the NEET examination. सिर्फ ऐसे क्वेश्चंस मल्टीपल चॉइस क्वेश्चन में निकालने का कोशिश करो. ओके मिराज एंड मोनिका, राइट अजय. नाउ limitations of valence bond theory. Valence bond theory also has some limitations. I could start from Lewis theory, Lewis dot structure. उसको NEET में कुछ questions आने का कम संभावना है. So I just want to take the valuable time from you and us to give direct score for the examination marks. Ready for that limitation? Formation of oxygen molecule. Oxygen is paramagnetic. This paramagnetic behavior of oxygen is not explained by using of the valence bond theory, and also it fails to explain the bonding in electron deficient compounds as well as metals and metallic bond, everything. And also during that time quantum mechanics slowly is developing. So this valence bond theory is not given a mathematical approach in the quantum mechanics. So valence bond theory has its limitations. I don't say it is failed. Okay, Linus Pauling is worked a lot based on this, right? And going for the requirement of hybridization. So after hybridization, I just want to go for kind of VSEPR theory and mix करके एक prediction of the shapes and different molecules we can see. So in VBT, the ideal hybridization was required to explain the phases, like number of bonds formed, the equivalence of bonds in some cases, and the stereochemistry of the molecule, and also the better overlapping of the orbitals. So these are the requirement of concept of hybridization. Otherwise, everybody stick to this VBT only. And how to just give the calculation of number of hybrid orbitals. I don't want to discuss about each and every hybridization, because that is just like an intermediate or a board level discussion. Now we are in cracky points. We have to discuss about the cracky points to say the hybridization or any points in this chemical bonding. Ready with us? Okay. So steric number से hybridization depend करते हैं. Steric number is equal to half into V plus or minus Q. So V is a volume shell electron of the central atom. I mean to say number of valence electrons. Number of valence electrons beta. Okay. And M is equal to number of monovalent atoms, just like sirf hydrogen and halogen that is attached to the central atom. And Q is the charge on the species. Agar charge nahi hoga to Q 0 le lo. If the negative charge is there, make it positive, and the positive charge is there, make it negative. Are you getting or not? Okay, let us discuss about this. And the rules for hybridization. Now you just see here, if H is equal to 2, मान लो ये sp hybridization होगा, H is equal to 3, sp2 होगा, H is equal to 4, sp3 होगा, and H is equal to 5, sp3d होगा, okay, H is equal to 6, sp3d2 होगा, H is equal to 7, sp3d3 होगा. ये शानदार खतरनाक स्लाइड है. Everybody take a screenshot of this. Everybody take a screenshot of this. So you can find hybridization for any simple inorganic molecule by using this particular slide. Okay, we'll do some examples as well if possible. Bachcho, any doubt, Monica? Monica, very good. Watch duration is good. Students attendance is good. And chart rate बहुत कम आ रहे हैं. It indicates that you are not asking doubts. Please ask doubt now. I am going to explain. Array, I am a senior faculty and standing in front of you and asking a doubt. Okay. Getting the answer from a senior faculty is actually, it's a gift to you. Use it. Okay. Now let's talk about rules for hybridization. Everybody follows the hybridization, but the following hybridization require what is the actual rule. So orbital similar energies only belong to the same atom or ion can hybridize together. Okay, and they should have nearly the same energy. Number of atomic orbitals that are involved in the hybridization should equal to number of hybrid orbitals that are formed. Okay, and also most hybrid orbitals are similar in shape and energies. Sometimes dissimilar shapes also there, dissimilar energies also there, but mostly, I say mostly. Okay, if you want to go with sp3 dehybridization, 5 hybrid orbitals will be there, 3 are in the equatorials and the same energies, and 2 are in the axial will have the different energies. Okay, for equivalent hybrid orbitals, orientation space is determined by, so point 1, yeah, the number of orbitals mixed and consequently number of hybrid orbitals obtained, and which of the x minus x and y and z axis preferred by the orbitals when they are in the pure. But in case, in generally assumption होता है क्या, z axis is considered as internuclear axis. Okay, and also for the type of hybridization one can predict the geometry as well as bond. So I just want to show you a pure which has been used for the build-up in a hybrid orbital is no longer available to hold the electron in the pure form. Once these pure orbitals, pure orbitals होता है क्या आपका जो मान में है s orbital, p orbital, d orbital, f orbital, these are called pure orbitals. Once they form in the hybridization, they lost their previous identity and forms new identity. Okay, there is no more pure orbitals. Now let us talk about if it is s p hybridization. This is formed by the combination of s and p. So it is going to be linear geometry बच्चों, ठीक है. So Mirage, if sp2 hybridization, it is triangular planar, bond angle is 120, and if it is sp3, you are going to have a tetrahedral, the bond angle is going to be 109.5 degrees. This is called tetrahedral angle. And if it is sp3d, it is going to be trigonal bipyramidal geometry. You're going to see 120 and 90 degrees. And also sp3d2, 6 steric number 6 octahedral hoga, and every bond angle is 90. Every bond angle is going to be 90. And this can give you what kind of pure orbitals are involved. So you can say sp, sp2, sp3. It can use pz, px, yz, any orbital. When it comes to sp3d, you use dz square. sp3d2, you use x z square and x square minus y square. This is more specific in the case of complexes, rather simple inorganic molecules. It varies as well. Depending upon the geometry, it varies. And also equivalent hybrid orbitals. If all the hybrid orbitals after hybridization are equivalent, as I mentioned, if you can say sp2, sp3 kind of orbitals are equivalent, all are similar shape and similar size. When non-equivalent, they are not equivalent. So they will have sp3d, the 5 hybrid orbitals are not equivalent. And there are 3 hybrid orbitals which are equatorial, will have the same, and you have axial or different. Similarly, sp3d2, the same way, sp3d3 in the same way. Okay, and you are going to see Drago's empirical rule. Now we are going to see detailed picture about NEET in-depth questionnaire. According to this rule, whenever phosphorus and non other elements over phosphorus के बाद, okay, the attached to the hydrogen atom in such compounds, lone pair generally do not participate in hybridization. मैं क्या बोलना चाहता हूँ यहाँ पे, this is very important. So NH3, nitrogen is there and the lone pair is in the hybrid orbital. pH3, the lone pair of electrons are not in the hybridization. sp3d is non-equivalent. Yes, Monica. Yes, it is. Yes, it is correct. Okay. And example pH3, H2Se, AsH3, SbH3, BiH3, H2S, H22E. These are all following Drago's empirical rule. So actually he observed, sir, empirical, he said. There is no experimental evidence as well. So from third period onwards, down the group, hybridization is insignificant. That is simple version of this Drago's rule. And let us see the applications of this Drago's rule even. What is affecting on the bond angles? The compound in which the hybridization does not take place possesses bond angle nearly 90. Yes, it is. Look at here. Ammonia, of course, it is sp3, confidently it is forming, so that the bond angle is nearly expected to be 109 degrees, so it is around 107. But here phosphine, arsine, stibine, the bond angle is nearly 90. The bond angle is nearly 90. The bond angle is nearly 90. These bond angles are important. An abrupt decrease in the bond angle you can see here. Got it? So this is how you need to understand this Drago's rule application. Clear? And Drago's rule, the term Drago's rule is not given in the NCERT, but observation of this bond angle is connected to this NCERT P block group 15 and it is there in the NEET released syllabus. Yes, it is there in the NEET released syllabus. So P block, study of ammonia is not there, study of nitric acid is not there, but in the P block a table form is there, observation of physical properties, gradation in the physical properties and their oxides and hydrides and their property and the increase and decrease in their property can be studied, and it is the application of the Drago's rule. Bachcho, hope you are understanding clear. Lovely, Bachcho. Next, determination of Lewis basic strength. Yes, of course. So hybrid orbitals show better basic character. Hybrid orbitals show better basic character than unhybridized orbitals. So that unhybrid orbitals, as they have more directional character. So I just want to say, example, NH3 is a better Lewis acid than PH3. NH3, a lone pair of electron is present on the hybrid orbital of sp3. So better donor, because electron cloud is accumulated. So that can be given, intensity of the electron cloud is more, so it's a better base. Whenever it is not in the hybrid orbitals, the p orbital is distributed around these big larger size of phosphorus, so it is not effective donor. I would say it is a weaker Lewis base. Okay, Monica, hope you understand, this is very important. And also similarly you can see NH4 forms easily but not PH4. This is the example for that. And also NH3 readily react with water but not PH3. So I just want to give you the application, and this is the evidence, practical evidence. Yes. Roshni, Miraj. Okay. Make a note of it, bachcho. Next, let's see VSEPR theory, valence shell electron pair repulsion theory. According to valence shell repulsion theory, a shape of the molecule is decided. How to decide the shape of the molecule? The shape of the molecule is decided by the electron pairs present on the central atom of the covalent molecule, polyvalent covalent molecule. So, the central atom has electrons in its outermost shell as pairs. Electron jodi jodi rehte. And these pairs are two types, lone pair of electron and bond pair of electron. And this lone pair of electron and bond pair of electron, and these electron pairs make repulsion among themselves. Excuse me. Yeah. Make repulsion among themselves, and these repulsions decide a lot. And bond pair and lone pair make the repulsion. So, lone pair repulsion is always greater than lone pair, and bond pair repulsion is greater than bond pair repulsion on bond pair. And the shape of the molecule is based on the steric number. Steric number includes the sum of the lone pair and bond pair, geometry of the molecule, whereas the shape of the molecule is decided by only bond pairs but not the lone pairs. Okay, so the steric number, so electron pairs tend to minimize the repulsion. For 2 electron pairs is linear, for 3 electron pairs is triangular planar, 4 electron pairs is tetrahedral, and 5 electron pairs are trigonal bipyramidal, okay, and 6 electron pairs are hexagonal. Like that it goes octahedral, okay, and repulsions among the electron pairs, lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. So, we are eventually taking the connection between the VSEPR theory and hybridization now. Let us talk about when lone pairs are present, the bond angles are smaller than the predicted. That is a noteworthy point. Bacho, this is a noteworthy point. When lone pairs are present, the bond angles are smaller than the predicted. This statement is only used for the elements present in the second period, but not the third period. This is on the central atom ka hai. ठीक है? And also lone pair choose the larger side, example equatorial or trigonal by equatorial position of the trigonal bipyramidal. That's very important, noteworthy points, bacho. And if all sides are equatorial, so lone pairs will be trans to each other. Lone pairs always in the opposite sides to each other. And also you can say double bond occupy more space than the single bond. So, as compared to double bonds causes more repulsion with a single bond, and bond pairs to electronegative substituents occupy less space than to more electropositive substituents. And based on that PCl5 combination, PCl3F2 combination, everything can be decided based on that. And also to the above, Drago suggested that various following an empirical rule which rationalizes and very small angles nearly 90 degrees in phosphine, arsine, hydrogen sulfide, and which all compatible with the energetics of the given compound for the hybridization. Monica, fine. If the central atom is in the third row, mean to the third period, this electronegativity rule and the lone pair of electrons doesn't work. And let us talk about the idealized orientation of the electron pairs leading to the minimum repulsion according to VSEPR theory on the central atom. Let us talk about number of sigma bond pairs, geometry, okay, bond angle, shape and examples. Let us talk about 2 sigma bonds, 2 bond pairs, that is going to be linear. So, it is going to be A bond pair here and a B bond pair here. So, 180 is the angle. So, here you can say NO2 plus N2O and CO2, cadmium iodide, mercury chloride, silver cyanide, etc. will come in this. And also you can say 3 lone pairs are not there, only we are talking about the bond pairs. It is going to be a trigonal planar. Bond angle is going to be 120, here 120. Monica, fine. Okay, Roshni and Miraj. Now you can see here example BF3, BCl3, BBr3, BI3, and COCl2 and SO3 NO3 minus and carbonate and methyl carbonium ion. ऑर्गेनिक केमिस्ट्री का जहाँ पर कार्बो कैटायन आता है ना, यहाँ पर कार्बन sp2 होना है, ट्राइगोनल प्लानर ज्योमेट्री आना चाहिए. Yes, that's good. So now if 4 electron pairs are there, it should have tetrahedron, and the geometry over here should come to be 109 degrees 28 minutes is the bond angle, and it is going to be CH4 NH4 plus BF4 minus and ASH4 plus PH4 plus SNX4 and sulfate POF3 or POCl3, perchlorate ion PCl4 plus and XCF4, and many ways it is going to be tetrahedral. So don't leave this concept alone. We are discussing kind of different shapes of the molecule. You please make use of these examples, use these concepts and apply in solving multiple choice questions. Are you getting or not? Clear? And that's good. Find if it is 5, it is going to be trigonal bipyramidal. So it's a trigonal and bond angle is going to be 120, and it is a bipyramidal, bond angle is going to be 90 over here. So example, your favorite example, PCl5, PF5, XeO3F2 and SbCl5 and also VF5, vanadium pentafluoride comes under this category. These are all only bond pairs are there in these structures. If lone pairs are there, they are going to have distortion. Let us use this distortion over here. So 6, it is going to be octahedral, S sub 6 is the best example. Okay, talking about 7, it is going to be pentagonal bipyramidal sp3d3 hybridization. It is going to be capped octahedron, capped trigonal prism structure. And you can see the shape of some molecules having stereochemically active lone pairs. So if the lone pairs of electrons are there, it is going to have the repulsion. If the repulsion, just to see, so if the number of lone pairs and bond pairs are 3, steric number, you can say steric number. Okay, if steric number is 3, उसमें क्या ट्राइगोनल प्लानर आना चाहिए एंड sp2 आना चाहिए. 2 बॉन्ड पेयर्स मान लो उसमें एक लोन पेयर है, इट इज गोइंग टू बी वी शेप और बेंट शेप. इफ इट इज 4, it should be tetrahedral geometry and उसमें 3 variants आ सकते हैं and 3 bond pair 1 lone pair, it is going to be trigonal pyramidal. 2 plus 2, it is going to be V shape. It is going to be 1 plus 3, it is going to be a linear. 1 bond pair हमेशा linear आ सकते हैं, example HXB. Okay, and also you can see if it is sp3d trigonal bipyramidal, it can be 4 plus 1, 3 plus 2, 2 plus 3. If it is 4 plus 1, it is going to be seesaw shape. You are going to be SF4 is the best example. Okay, and if it is 2 plus 3 bond pair, 2 lone pair, it is going to be T shape, and it is going to be T shape. And whenever it is T shape, you are expected to get a 90 degrees, but it is less than 90 degrees. Okay, because of the lone pair of electrons. And ClF3 is the best example. So how do you say that? You can say Cl, it has 7 electrons in its outermost shell. 1, 2, 3, 4, 5, 6, 7. F, and it is going to be F, and it is going to be F like this. So it is going to be T shape. So 3 bond pairs and 1 lone pair, two lone pairs, and it is sp3d. So 2 plus 3, it is going to be linear. Your favorite example ICl2 minus XeF2 I3 comes under this category. Okay. So Maunika, अगर कुछ doubt है ना तो पूछना बेटा. Now I am going to discuss some more details about this. So in this VSCPR3 octahedron sp3d2, in this sp3d2 5 plus 1 भी हो सकते हैं. Yes, 2 lone pairs and 3 bond pairs, and 4 bond pairs and 2 lone pairs, and 5 plus 1 you are going to get a square pyramidal and example BRF5, and 4 plus 2 it is going to be a square planar. You can see a planar structure. It is a square planar structure, ICl4 minus. And pentagonal bipyramidal, it is sp3d3 hybridization. It is going to be 6 plus 1 and it is going to be 5 plus 2. And it is distorted octahedron and pentagonal planar. So it is going to be XeF6, XeOF5 minus, and it is pentagonal planar XeF5 minus. Like that, as you move ahead, you are going to see classify steric number 6 can be written as 5 plus 1, can be 4 plus 2. If steric number 7, it can be 6 plus 1 or 5 plus 2. Like that you classify and you just apply the same concept in the NEET examination, crack for the NEET MCQs. Ready? Any doubt, Monica? And let us see here comparison of bond parameters. So bond parameters. Today's session we are discussing about cracky points in a rapid fire in the chemical bonding. So this particular session is intended to give more booster setup for this NEET chemical bonding, also supporting laterally with P block elements. है ना? Clear? Wonderful. And more number of electronegative elements, bond length decreases. Carbon with hydrogen. Carbon with hydrogen. Okay, fluorine is there, more electronegative. Fluorine is there, more electronegative. Okay. Fluorine is there or more electronegative. So as the number of electronegative increases, bond length decreases. ताकि इसका D1 is greater than D2, D3 and D4 because electron is pulling. Got it? Similarly, you can see always compare bond length for common atoms. You want to compare nitrogen to hydrogen in NH3. You want to compare nitrogen to fluorine in NF3. And this you can't compare. So bond length of nitrogen to hydrogen, nitrogen to fluorine not comparable. Mind it. Yes, definitely I'll explain it. That's the way you need to ask a question. So as the electronegative elements is increased, the electrons are being pulled. So that a D2 D1 से कम होगा. And here more pulling effect is there. And D3 D2 से कम होगा. Are you getting or not? Monica, thumbs up, fiery emoji. Okay. और कुछ है? बात करते रहो. When you say na, we'll understand. Okay. And also you can't compare the length between nitrogen to hydrogen in this molecule and nitrogen to fluorine in this molecule. Always compare for the similar atom. Fluorine अलग है, chlorine, hydrogen अलग है. Can't compare them, है ना? And also practice problem. Compare the oxygen-oxygen bond length in hydrogen peroxide. It is D1 and O2 F2 is D2. And you can say D1 can be equal greater than D2, D2 can be greater than D1 or equal. You just tell me, or cannot be determined. So it's an outstanding question. Because of the electronegativity, this bond is pulled like this. है ना? So that what happens? The D2 is less, come close together, right? No, it is not. Yeah, it is a pulled like this means they don't stretch, they come close because they are not linear. Mind it. Okay, open book structure. Next, you can say shapes of hybridization of molecules. Okay, right. So steric number 2, it is going to be linear and it is going to be sp hybridization. Steric number 2, right? Yes. And quick rapid hybridization concept. Okay, and the shape is line, orbitals participated, it could be S and Px or Py, and it is going to steric number 3, and it is going to be sp2, it is going to be trigonal planar, and it is going to be, if it is a lone pair of electron is there, case 1 and case 2, 3 bond pairs, and 1 plus 2, 1 lone pair, 2 bond pairs, it is going to be 3 bond pairs, it is going to be shape planar trigonal, and it is 1 lone pair, 2 lone pairs and 1 bond pair, it is going to be V shape. Right? Similarly, steric number 4, इतना सारा combinations है. Hybridization is sp3 definitely, and it is a case 1 4 bond pairs tetrahedral, case 2 3 plus 1 3 bond pair 1 lone pair, shape is pyramidal, and case 3 2 bond pairs and 2 lone pair, shape is angular, water molecule के जैसे, and hybridization yes D3 भी है, yes D3 भी है, and it is going to be tetrahedral like MnO4 minus. So you just see this is exceptional cases, Cr2O7 2 minus, CrO4 2 minus. Are you getting or not? Take a snapshot of this, everybody, take a snapshot of this. 3 2 1, click it, click it. Yeah, now steric number 5, hybridization is sp3 dsp3, orbitals that are involved d z square px py pz, and it can have case 1 case 2 case 3 case 4, 4 cases, 5 bond pairs, tgbp trigonal bipyramidal bachcho. Okay, and case 2 4 plus 1, shape is seesaw structure, and case 3 3 plus 2, it is going to be T shape CLF3 का जैसे, and case 4 2 plus 3, it is going to be XEF2. These are all the kind of framing you should have in your mind, kind of a framing you should have in your mind, understand? Right? And it is going to have steric number 6. Steric number 6 means sp3d2, orbitals participating is dz square x square and y square, and you can have case 1 case 2 and case 3. Case 1 6 bond pairs of electrons, it is octahedral, and case 2 5 bond pairs and 1 lone pair, it is square pyramidal, and 4 bond pairs and 2 lone pairs, it is going to be square planar. Right? Everybody, Monica, take a snapshot of this, take a snapshot of this. 3 2 1. So it is going to be, these slides are going to be a simple revision for your preparation, a rapid revision for your preparation. And also you can have steric number 7. Steric number 7. In the steric number 7, you will be having sp3d3, what are the orbitals are used? You are going to have dx square y square, dz square and dxy. Okay, and geometry pentagonal bipyramidal, and case 1 7 bond pairs pentagonal bipyramidal, and you have case 2 6 bond pair 1 lone pair, shape is going to be distorted octahedral. And at last, before going for the session, I just want to talk about Fazan rule. Fazan rule says covalent character for an ionic compound, Fazan rule is there. There is no compound that has 100% ionic character. That is the rule number 1. Kamal kiya na? And the covalent character of an ionic compound can be explained with the help of Fazan rule. So Fazan rule says, like according to Fazan rule, covalent characters increases if cation behavior and anion behavior. In simple terms, cation and anion, and the shape of anion is deformed by cation. This is called polarization. So covalent character is directly proportional to polarization. This is what is meant by Fasan rule. So when it comes to the cation, small size of the cation, more charge on the cation, pseudo inert gas configuration of cation. When it comes to the anion, large sized anions and more charged anions has the more covalent character. So these are the catchy points where you need to have the exact version of this Fasan rule. And let us see factors of polarization. Size of cation increases, polarization. Size of cation increases, polarization increases. Okay, so polarization decreases, covalent character decreases. So an example, covalent character, beryllium 2 plus, magnesium, calcium, strontium, barium is a small and magnesium is big, calcium और बड़ा है, strontium बड़ा है, barium बड़ा है. So small cation will have the more polarizing power, it is going to be more covalent character. Similarly, charge, size of the anion, as the size of the anion increases, covalent character increases because the polarizability increases. You can see size of the anion increases, polarization increases, covalent character increases. Like that, you can also say charge on the cation, either cation or the anion, you will be having the same way. Okay, so polarization increases, covalent character increases. And also cation with inert gas configuration will have more polarizing power as compared to the cation with octet configuration. So that cadmium chloride and calcium chloride, cadmium chloride has a more covalent character as compared to the calcium chloride. Now you can say more covalent, less melting point, more ionic, more melting point. So more ionic, more soluble in the water, and more covalent, less soluble in the water. Like that, you need to have various comparisons. Okay, various comparisons. And you can see applications of Fasan's rules. Solubility, Ag2S is less soluble than Ag2O, okay, in water, because Ag2S is more covalent, bigger S2 minus ion. Like that, you need to relate FeOH thrice is less soluble than FeOH twice, because उसमें +3 charge है, उसमें +2 charge है. Understand? Clear? Similarly, you will be having color of the compounds. Actually, color of the compounds is generally for cations, but in case of polarization, the polarizability of anion makes it is colored. Like silver chloride is white, silver bromide is pale yellow, silver iodide is yellow in color. So due to covalent character and due to their polarization, color also introduced. It's very important. And similarly, SnCl2 is white, SnI2 is black. PbCl2 is white, PbI2 is yellow. Got it? And also variation in melting point. Melting point decreases for the covalent compounds and melting point is high for ionic compounds. Similarly, nature of oxides, very important point बच्चों. Covalent character increases, acidic nature increases, बेसिक नेचर डिक्रीजेस. खतरनाक पॉइंट, इनऑर्गेनिक केमिस्ट्री में ये पॉइंट ज़्यादा काम आ जाएगा. सो कोवेलेंट कैरेक्टर Na2O, MgO, Al2O3, SiO2, P2O5, SO3 and Cl2O7. Acidic nature of Li2O, Na2O, K2O, Rb2 and basic strength is increased. Okay, it all just like more covalent and less covalent. And today, next class we will discuss about the molecular orbital theory, as the time is very limited. So that today we had discussed about valence bond theory, VSEPR theory and hybridization and the combinations and bond parameters, bond length and bond angles and the Fasan rules. So when you talk about the hybridization, you don't directly get a question from hybridization. In that some twist will be there. Today we had a discussion about that kind of twist in the examination point of view. So you please stay tuned for us in this Infinity Learn YouTube channel. Please like our session, share with your friends and subscribe to Infinity Learn NEET YouTube channel, so that stay tuned for such type of sessions in every day 1:30, so that we can do the best for our NEET 2025 preparation. Okay, so we had a great swell of the session. Please like our session. Thank you very much. God bless you. Monica, bye bye. All students, bye bye. Happy New Year to you all. Take care. God bless you.